Hi folks, I'd like to welcome everyone to the November C++ users group meeting. What we're going to do tonight, we do need to wrap up the recording part of the session by about 8 o'clock. So we're going to let the presenter get going here real quick and do the presentations. And then we'll stop the recording at 8. And if there's other additional questions and stuff after the recording stops, we can keep going with that. I've only got one announcement so far. And as everybody knows, about this time of year, I'm looking for presenters for next year. So if you're interested in doing a talk next year, please get in touch with me. And with that, I'm going to turn it over to Diego from JFrog to talk about the Conan C++ package manager. All yours.
Hey, thank you very much, and thanks for inviting me to the meetup. So yeah, I'm Diego, and I'm one of the co-founders of Conan, and today I'm going to do an introduction to Conan. So first thing, if you want a T-shirt, the first 25 people that enter this form, it's not a raffle. The first 25 actually gets T-shirt. Okay, so please go take the QR code or go to this URL, and then you can put there your details, and we will be sending you a T-shirt, a Conan T-shirt, if you are one of the first 25 people. So this is the outline for today. First, there is an introduction section. I'm going to first explain how to use existing packages that someone else created for us. And I'm going to do it with a modern style, because as with C++, Conan is now 5 years old, and we have a legacy way of doing things, and we have a modern way of doing things. This way is transparent. I'm going to show you the Cmake transparent integration, both for using existing packages and also for creating our own packages. This is let's say the Conan basics. And then after, I have a couple of advanced cases. For example, how to work on more than one project, more than one package at a time. Also, how to do cross-building. And if there's time enough, I will be doing a small surprise. Okay, so let's start first with the introduction. Conan is an open source package manager. It's this MIT. You can do whatever you want with it. It is multi-platform. It will work in Linux, in Mac, in OS X, and it can target also any platform, even bare metal, embedded. It can use any build system natively, not wrapping with Cmake. If you are using Visual Studio, for example, Conan can do Visual Studio solutions natively. It's very stable, and the community is very large. There are tens of thousands of companies out there using Conan at the moment in production. From the architecture point of view, it is a client-server architecture. So there is the client tool that you run in your computer, and there are servers that store packages. We are running the JFrog ConanCenter. ConanCenter is the central repository for open source libraries that the community is contributing these recipes. ConanCenter builds them, actually builds more than 100 different binaries for each version of the library. And we manage and host this repository. And also you have Artifactory. You have a server that you can host your own private packages, and it is free. We have the Artifactory Community Edition, completely free, and you can use it for commercial purposes in your company without any problem. This is let's say the core idea of Conan. For a package, let's something with a name and a version like package 0.1, we have what is called a recipe. A recipe is a Python script that describes how to build binaries from sources. For every recipe, one recipe can create any number of binaries, depending on the configuration. So if we have a closer look to this model, we have something like this. For the package mylib 1.0, we have this recipe, and we have a bunch of binaries. Each binary has a unique package ID, and this package ID is computed as the hash of the configuration. On the right side, we can see this configuration. We have the settings. The settings, for example, is the architecture, the compiler version, anything that changes. If it changes it will have a different binary. Okay, so this is part of the configuration. And also the other part is the options. Whenever you change, for example, your package from a static to a shared library, you are going to have a different binary. So these options are also part of the configuration. We take this configuration, we hash it, and then we have these unique binaries. This doesn't mean that the process is not efficient, because one of the cool things is that when you're working and you're a developer machine or a CI agent that is building something requires one configuration to build, they want to build a configuration, only that binary will be retrieved. So as I said, in ConanCenter we have more than 100 binaries. Is not an issue, because when you are building for Windows, it will, and Visual Studio 15, it will bring only that binary for you. We will see that in action in a few minutes. The other cool feature of Conan is that it abstracts away the build systems. In ConanCenter, for example, we have more than 1,000 packages there with different build systems. Each one is using natively the build system that the library comes. It's Cmake, B2, Make, Bazel, whatever it is. And any package created with any build system can be consumed from any other package and any other consumer application with any other build system. Okay? And Conan abstracts away this with a mechanism that we will see later. Okay, this is more or less the introduction, and let's move to code. I don't like slides. I like showing things in real life. So from now, everything is going to be a demo. Okay. By the way, if you have questions, we will have in time at the end. Please take notes, and we will be talking later. Okay. So first, let's do a small application with libcurl. Okay. Let's do it. I'm going to show you here the code of a small application that I'm going to build. Let's open the code here. And this is the application that I want. It's an application that depends on libcurl. I need libcurl on my machine to be able to work, to be able to build this small application here. Okay, it's an application that is doing an HTTP GET request to a server that I want. Okay. The cool thing of the integration that I'm going to show you is the transparent integration. As you can see here, this Cmake list contains nothing about Conan. It's pure standard Cmake list. And this is the typical find package, and this is the standard target name that you will find in any example out there in the internet. That is curl in uppercase and then libcurl in lowercase here. Okay, perfectly normal standard Cmake. So what I need to do to declare my dependencies is to write a Conan file. The Conan file will contain a require section that defines the package that I want to use, or the packages that I want to use, and the version that I want to use. Okay, Conan can manage any number of versions of the same package at the same time and in the same cache as well. And after that, I will define my build system, my integration. In this case, I'm going to show you the Cmake new transparent integration that is composed by a generator that is called Cmake deps that manages my dependencies, and another generator that is called Cmake toolchain that will generate a Cmake toolchain for me. Okay, so with this Conan file, all I have to do to build my application is to write. I'm going to create a temporary build folder, move to it, and I'm going to do a Conan install. Okay, this Conan install will do a few things. The first thing that we see here is that it's going to fetch more than one library. Okay, I specified libcurl in my Conan file, but it's fetching more. Why? Because it is fetching the transitive dependencies. Actually, I can inspect my dependency graph with this command. It's called the Conan info, and it can print the graph, my dependency graph. I'm going to show you this file here. Oh, sorry, file HTML. And here we can see that I depended on libcurl, and libcurl transitively is bringing OpenSSL and setlib. The second thing that we see here is that it was really fast. okay, because it found precompiled binaries for my configuration. My configuration here, you can see it is Visual Studio 16, 64 bits and release. Okay. This configuration, there is a precompiled binary for this configuration in ConanCenter. So all Conan had to do is to fetch this configuration, this precompiled binary. It installed the binary, okay, and we're done. And the last thing that it did for us is, as I specified the generators, the Cmake tool generator and the Cmake depth generator, what it did, it generated a few files for me. For example, this toolchain file. So with these files, I can achieve my transparent integration. I can do a Cmake toolchain file, which is a standard Cmake mechanism, and then specify the toolchain. And then it will be, in this case, it will be configuring a Visual Studio project because I'm in Windows. As I told you, Conan is multi-platform. This works exactly the same in Linux, in OS X, and after we will also be cross-building. Okay, so this configure my project. I could open Visual Studio now and build from my IDE, but I'm going to build now in the command line because it's a bit more convenient for demo purposes. Okay, so this will be building my application. And finally, I could launch my application like this. It seems that it's working. Okay, it requires a URL to work. So I'm going to take this example URL, for example, that is a cat server. So as many developers love cats, I'm going to do this, which is bringing a random cat fact, like for example, like kittens remains with their mother till the age of 9 weeks, or I could be fetching another cat fact. Okay, so it seems our application with libcurl and OpenSSL and setlib in Windows now is working. Okay, so this is very cool. We learned how to use libraries. In this case, libcurl, OpenSSL, setlib libraries. But very soon, when we released Conan, people started to ask, hey, can I put an executable, an application, a tool inside a Conan package and then use it? And the answer is yes. It's basically the concept of build requires was born. The build requires is another type of requirement that is intended for tools. Tools like Cmake itself, for example. I can write something like this. And it will be fetching a Conan package containing Cmake 320. And Conan never touches your system. Conan works at the user level. It doesn't require sudo permissions. It doesn't require administrator permissions. Okay, it works always at the user level, and it will not modify your environment. In order to use Cmake 320, I'm going to use here a virtual build environment, and I will show you how to use it. Okay, so with this Conan file, I can do the same. I can do a Conan install. And in this case, we will see that we have the requirements the same as before. And now they are cached. They are not downloaded anymore because they were downloaded and the cache contains them. So it's efficient. It will not re-download them again, of course. And in this case, it detected that Cmake is a new requirement. It's a new build requirement. So it's fetching Cmake, it's uncompressing Cmake, and put it in my cache. Okay, perfect. So the previous example, I was using Cmake. It was using my system Cmake. My system Cmake is this one. Is 315. Okay, actually, if you want to see my path, this is the path to my system Cmake. Okay, the Conan package that I install right now, with this generator, I can activate this environment and I can use this Cmake. This generator, what generated for us is this file. So I can activate this environment. Now, if I check which Cmake is going to show me a path, this is the path to the actual to the current Conan cache, and we can see that is the Cmake now is in the cache in the version 320 and in this path. So if I now run Cmake, it's going to be Cmake 320. Okay. And again, this didn't modify the environment. This is a local activation of the environment just for my session. And of course, I can deactivate the environment anytime, and I will be back to my system Cmake without any problem. So with this mechanism, you can have installed as many Cmake versions as you want, and you can be activating and deactivating them at will without affecting the system. And the same with any other tool that you might want to use. Okay, let's wrap a little bit. So with Conan files and the command Conan install, we learn how to install libraries, and we learn how to install tools as well. These tools they were fetched from ConanCenter. Okay, ConanCenter contains more than 1,000 recipes, each recipe with multiple versions, and each version with around 100 or 130 different binaries. Okay, you can use specific versions, and if you don't have a precompiled binary for your configuration, okay, you can always build from sources. Okay, Conan doesn't mandate to use only binaries. You can do a Conan install -- build, and it will be building from sources with your configuration as well. Let's move to the creating packages. Those packages, they were created by the community for open source libraries. Now, the power of Conan is that it's very easy to create your own packages for your own libraries and your own code, and then share it with your team and share with your colleagues in your company. So you can reuse those binaries very easily, and then your CI can be fast, and your developers also can be faster installing new things. Okay, so let's do it. Let's create packages. I'm going to move to another folder. Here I have a very simple library. So I'm going to show you this library here. This is the library. Okay, this is a hello world library. As you can see, with only one method. It is called the hello method. Okay, and this is the implementation of the hello method. It's just printing some things to a standard output, and also some diagnostics that we will find useful later. Okay, but it's pure C++, simple. And again, this is the transparent integration. This doesn't contain anything related to Conan. This is a pure standard Cmake. Okay. Now I'm going to show you the Conan file to create Conan packages. So now we are moving from a Conan file.txt that was good enough for consuming, but not good enough to create packages, to a Python version of the Conan file. This is the Conan file.py. Okay, and we can see here a few things. We can see here first the metadata. We have things like the name and the version of the package. Okay, you can also add things like the license, the author, things like that. The second important thing is the binary configuration. If you recall the binary model, everything that is hashed into the package ID is defined here. Here I'm defining, hey, this package, if you change the operating system or the compiler or the build type or the architecture, then you are going to get a different binary, a different package ID. And by the way, compiler inside, it contains the compiler.version, compiler.runtime, and so on. And the same with the options. This package can be built as a shared library and as a static library. Okay, let me skip to the important part of the recipe. Okay, as you can see here, you can identify, even without knowing much about Conan, you can identify what it might be doing. Okay, the first part that I'm going to explain today is the generate. The generate method here is going to prepare my build. After it runs the Conan install, after it installs the dependencies, this method here is the one responsible for creating the necessary files for my build. In this case, it's creating the Conan toolchain.cmake file for us. Okay, and it is explicit here because you can configure things. If you want, for example, to inject some variable like these variables, you can inject Cmake variables like this, for example, in the toolchain, or you can add preprocessor processor definitions like this. So there is syntax, so you can configure the toolchain. Actually, the Cmake toolchain helper here has a lot of configuration if you want to use it. Okay, then after the necessary files have been generated, the build method is in charge of building. In this case, it is using the Cmake wrapper. This is a very thin wrapper around the command line, around the Cmake command line. And this configure will be mapping to the Cmake to this line, and this build will be mapping to this. Again, here, if you want to use your own build system, even a proprietary one, you can just write here the commands that will be launching your build. Okay, again, Cmake is not mandatory, it's just an example here for this meetup. Then the package method is the one defining the artifacts from the temporary build folder. It will be extracting the final artifacts, typically the headers and the library in this case. But if there were something else, for example, I want to make sure that a license file is being packaged, I could be something like this. Hey, copy license everything to a folder that is called the license folder. Okay, so here you can see more or less the spirit of this Conan file, that you can script what you want it to do. And it's Python code, which is reasonably understandable and very practical. And finally, this is a very important method. This is the package info method. That is the one designed to provide information to the consumers. This is the method that decouples the build systems. In this case, this method is telling, hey, if you are going to use this package, you are going to have to link with a library that is called hello. Okay. This information here is encoded to the generated files that the consumers will be generated. This is also using some defaults. Okay, so it's a bit transparent here. I don't need to write it, but this is already a default. Include dirs equal include. Okay, so I don't like to write it, but this is actually happening. As you can see, the CPP info structure is defining all the information about my final package for the consumers that they don't need to figure out. They don't need to be thinking, hey, where are they include the headers, or where are the libraries, or if the package name is changing, for example, if self settings build type equal debug, then you can do this. Typical when you have a library is called with a D postfix in debug, you can do this. And this will be providing the information to the consumers automatically. They don't need to recall that the library is called hello div when they are in debug mode. They say, hey, I'm in debug mode. And automatically they will be getting the right files with the right information for this to work. Okay, so this is basically the recipe. As you can see, it's a number of methods that describes how a package is built and packaged from sources. By the way, you can also package, if you want, you can also package precompiled binaries. If you have your own, I don't know, proprietary binaries, or someone that sold you are buying some closed source binaries, you can also put them inside a Conan package. It's also very straightforward. Okay, so with this recipe, all I have to do is do a Conan create command. And the Conan create will be basically taking this recipe and executing step by step. Here we can see is calling the generate method, then it's calling the build method that will be calling Cmake with the toolchain file. It will be actually doing the actual build. Finally, it will be calling the package method that in turn is calling Cmake install and getting the final artifacts into my package. Okay, so this was a local build in my machine. If I inspect my local cache, I will see that I have, besides the packages that I was using in my previous example, I find that I have a hello 0.1 in my local cache. If I further inspect this package, I will see that I have one binary, because Conan create by default created a binary for my configuration, for my default configuration. But this is the thing that I can scale to infinity. Let's say that, for example, I need to maintain this library for an ATM machine that is running Windows, but for reasons I need to use an older Visual Studio version. I'm going to use 15. And also, the machine is a 32-bit architecture, so I want to change this. And as I need to deploy the binary, I'm going to link the runtime of Visual Studio statically. So I can do the same as before, Conan create, and in this case, I'm going to specify the differences, the configuration. First, I'm going to build for 32 bits, then I'm going to use the compiler version is 15, and then the compiler runtime is going to be the static runtime. Okay, so this is launching again. The same steps is going to build from sources. Now we can see that it's going to build to 32 bits. We can see that it's using the Visual Studio 15 2017 instead of Visual Studio 16 2019, which was my default. And this is building again and packaging new binaries. So if I inspect again my local cache, I will see that I have these two binaries, each one which is its own configuration. As you can see here, this is the 64 bits and this is the 32 with the static and 15 compiler. And of course, each one will contain its own package ID. Okay, this is the process that we can use exactly the same in Linux, and it will be using the Linux configuration. For example, I can build and I can cross-build for Android. This same library, if I need to maintain also this library for the Android application that my users are going to use, okay, I can do it. I'm going to introduce the concept of profiles. Instead of typing everything in the command line, it's more convenient. Sorry, not this one, this one. It's more convenient to put those settings instead of the command line. I can put them in a file, because this file I can distribute very easily to my team, and it can also be distributed to the CI agents, so everyone is using the same profile, the same configuration inputs. Okay, and beyond specifying the operating system Android, the architecture is going to be ARM-v7 and so on. I can also provide some configuration. For example, for the Android build, I need to specify where is my Android NDK. And I'm also going to specify that I'm going to use the Ninja generator because I want to do my build with Ninja. So all of these details can be specified in my profile, which is called, in this case, is called Android TXT. Okay, so with this profile, I can do a cross build with Conan create. And again, I could pass everything on the command line, but it's just easier to use this profile file. So with this Android profile, we can see here it will be running the same steps, but in this case is cross-building to Android ARM-v7. And here we can see that it's using the Android Clang compiler, doing the build and same packaging the different artifacts. Of course, in this case, they are no longer called .lib like Visual, but they call .a. And the package was created for Android. So now, if I do again the Conan search, I will have the three different binaries. I will have the binary in my local cache for Android ARM-v7, for my Windows default, and also for that legacy ATM machine that I need to maintain with 32-bit architecture. So I have these three binaries. Perfect. I created these three binaries locally in my machine. Now I want to share them with my team. Okay, so the process is I'm going to upload them to my own Artifactory instance, and I'm going to show you here. This is the Artifactory that I'm running here. Okay, so again, this is the Artifactory, as you can see here, the community edition. As I told you, this is completely free. You can download it from our webpage and you can be using it. It's very powerful. It's good enough for commercial purposes. So you have the whole stack, the whole Conan stack for free. Okay, so I have here this repo. So the process to upload these packages to the repo is basically Conan upload. I'm going to upload to my Artifactory instance, and I'm going to upload all the binaries that I created. Okay, asking for confirmation, yes, I do want to upload, and then it will be uploading those packages. If I go and inspect my repo, let's refresh. And I have my hello package here. If I have more than one version for hello, I will see all the versions here, of course. In this case, I have only one version. And if I inspect inside, I will see that I have the 3 packages. Okay, I have the 3 packages. I have the binary here. Let's see the information. I have the binary here for Android. I have the binary here for Windows 64 bits, and I have the binary for Windows 32 bits. And if I'm maintaining a multi-platform application and library, I will have also here in the same place, I will have my Linux binaries and my OX binaries and my binaries for my embedded platform, which is bare metal and everything. And I can see all the different binaries for all the different versions here in the same place, in the same server, which is super cool to maintain, especially if you have a big application with many libraries and components. It's very cool to have all of them in the same place for all the technologies that you are maintaining. Okay, so let's do a quick wrap up of the creation. So we have learned that the Conan create command together with the Conan file.py recipes can create packages that we have different configuration inputs, and we have the profiles that we can provide to the command, and we can create packages in our computer, and we can, with the command Conan upload, we can upload them to our own server. And again, the Artifactory C is completely free, so you can use it. Okay, so as I told you, I'm going to move to the a bit more advanced stuff. This one, the editables, I'm going to explain the concept only because I want to be on time, and I want to be able to explain a little surprise if I have time enough. And then the cross-bidding, I plan to do the live demo as well. So let's first explain quickly the editable concept. And this is a bit more advanced, but it's something that happens in real life. So now let's say that we have the hello example that we were doing before. Okay, and we have, if you remember my core small application, let's say that we want my core application to be using the hello package. Okay, and the hello package is my own package that I'm developing this package. Okay, so every time that I do a source code change in the hello package, okay, if I want my core application to be using this package, I need to do the Conan create. Because the Conan create is the process that is taking this recipe, put it in the Conan cache, building the package, and making it available for consumers to use. Okay. The problem here is that the Conan create is relatively slow because it builds from scratch. It does a clean build. I mean, and it's totally desired. You want to have a clean build when you are creating packages because it's very important to have a clean, reproducible build in for your package. So if you have this process and you need to be testing the hello changes in the micro application, then this can be a bit inconvenient because for every change that you do to the hello code, you need to do a whole rebuild from scratch in the cache. Okay, so this is the problem that editable packages solve. Okay, so what is the concept of editables? Let's say that we have this hello, and we do what we learned in a few minutes before. We do the Conan install, and we just run Cmake, and we are able to build our hello locally as a consumer. Okay, the same as we did with the micro application, exactly the same steps. Just Conan install and then calling Cmake to be able to build locally. Then the editable is actually a Conan command. You can run Conan editable add. You point to the folder that you have your hello 0.1 recipe, and then specify the reference hello 0.1. That means A, whenever someone contains a requirement to hello 0.1, instead of going to the cache to find that package, you are going to go to this folder, to this user folder directly. Okay. Then after you write the Conan editable command, you go to the micro project and then you type Conan install. This Conan install will find hello 1.0, but not in the cache anymore. it will find Hello 1.0 directly in the folder that you are developing the Hello 1.0 package. Okay, and then suddenly you have the two things in user space, and you can be working together both at the same time. This is the demo that I'm going to skip because I want to try another thing later. Okay, but the cool thing is that you have these two things. You have the micro application package and you have the Hello package. You can have both of them in two different IDs, in two different instances of Visual Studio, for example. Okay, I have a demo that you can actually load the project of Hello in the micro application, and then you have both sub-projects in the same solution. And you can just be right-clicking in your IDE, and you'll be modifying the code of the Hello package, and then running the micro application directly in the IDE without touching a Conan command. You just set up the two things, connect them, and then from there you can be hours in your IDE, just in your IDE, developing code without needing to be running Conan commands, which is also, I mean, desired by developers. Okay, if you are already using Conan and you are getting to this stage, which is an advanced case, okay, please know that this is possible. And if you have any question or you want a video of this demo, please write me, and I can provide you with the details. Okay, the thing that I'm going to demo now is the cross-building, because I'm going to show a very powerful feature of Conan that is the way that it knows how to do cross-building. And I'm going to throw it a challenging example, an example that actually Cmake by itself doesn't handle natively. Is this case, the case that we have a package, in this case protobuf, okay, that contains two things. It contains a library, and it contains an executable that uses this library, that links with this library. It contains both things. Okay, in this case, the executable is a code generator. It's an application that you provide a template, a proto file, and it will be creating C++ headers and body CPP files with the implementation with the stubs to be writing protobuf applications. Okay. The challenge here is when we have this. Let's put the previous example that we were developing this application for an ATM machine. Okay, and this can be, I'm going to run this because I can run everything very easily in my Windows system. But this is exactly the same as cross-building. Okay, let's say that we have the ATM machine. The ATM machine, as I told you, is a 32-bit architecture. I need to be building with the Visual Studio 15, and I need to be statically linked the runtime. Okay, so when I build in this, and if this communicates via protobuf, I need the protobuf 1.0 package, okay, built with these settings, with 32 bits, basically with the ATM Model 1 profile, okay, which will be the profile that is going to be also used by the ATM Server 1.0 application that runs in the ATM machine. Okay. But when I'm developing, I'm not developing in the ATM. I'm developing in my Windows machine, which is 64 bits, etc. And when I'm running my build, the Proto-C application that I need to be running is a Proto-C in my Windows, in my 64 bits architecture and everything. So in this case, I have another different profile. I have what is called the build profile. The build profile in this case contains my current Windows configuration, which is the Visual Studio 16, dynamic runtime, and everything. If I was running, let's say the ATM machine is a Linux machine, the setup will be exactly the same. The build context will be exactly this one, the same one, and the host context will be an ATM Model 1 that will contain things like Linux, compiler GCC, and things like that. And it will be a cross-building. But the concept here is that I have two different instances, two different binaries of the protobuf package in the same build. It's not different build, just the same dependency graph. I have two different instances, one for the host context and the other for the build context. Okay, and this is what can be done with the profiles. I'm going to show you. So here I have my two packages. Both are very simple. So I have the protobuf that contains both an application and the library, and I have a fake ATM server. Okay? So both are hello world examples. So this is actually printing some stuff and calling protobuf. And I also have the two different profiles. As I told you, this is my native, my build. My Windows PC is the build profile, okay, containing these details, and my ATM Model 1 is my host profile. Is the place. This is the GNU naming. Is the place when I will be building. I will be running my final code, which is a 32-bit architecture machine, and it's going to run with the static runtime embedded in the application. Okay, so with these two profiles that I'm showing here, I can do something like this. First, I'm going to export the protobuf application. And then I'm going to do something. I'm going to do the Conan create of the ATM. And I'm going to specify the two profiles. Profile build is going to be Windows PC, and the profile host is going to be the ATM Model 1 profile. Okay, so let's do it. Okay, of course I didn't build the binaries yet. I can see that this is the what Conan needs to build this. Okay, we can see here that the important thing is that we have two different packages of protobuf. We have protobuf with this package ID, okay, which will be the one for the host context. And we have protobuf as a build requirements. This is the one that needs to be running the proto-C executable. Okay. And in this case, I don't have these precompiled binaries yet. I'm going to build both in the same build. I'm going to add the build missing, specify to btLNA. If you don't find the binary for this, please build it from sources. And this is going to do a bunch of stuff. First, it's going to start building protobuf, and it's going to build the two things. It's going to build the protobuf for the build context, containing the proto-C that I need to run on my Windows build machine. And now it's going to build the protobuf cross-build for the 32-bit architecture for my host machine. Okay, so now the first thing that it did, it was building the two different flavors of the protobuf for the build and host context. Then it started to build the ATM server. Okay, if you recall my dependency graph here, we have three different things to build. We have the protobuf for the build context, we have the protobuf for the host context, and finally, when both are built, then it can build the ATM server package. So, sorry, I didn't show you this, but the ATM server package, this is the interesting piece here. Okay, so in my build method of the ATM server recipe, I'm running proto-C. So I'm faking here that I'm calling the proto-C in the build step. This will be the step generating the source code to be built, and then this will be using the generated code and embed it into the application. Okay, so here what we need to see is in the ATM server build step, it is running proto-C. Which proto-C it is running? It is running the proto-C that is for 64-bit architecture for my Windows build machine. And this is Visual Studio 1929. By the way, is Visual Studio 16. It's my modern Visual Studio in my machine. Okay. And finally, when it builds the ATM server, calling proto-C and protobuf, after everything is built, it will be launching the ATM server application. And in this case, as the ATM server application is running, is calling protobuf, we can see here that the protobuf that is actually running is the 32-bit one that is using the Visual Studio version 1916, which is Visual Studio 15. Okay. Good. So let's do a brief recap of what we done here. We are using the two profiles, which is the build and the host profiles, to be able to do different builds for the two different contexts and do cross-building using even the same recipe, the same protograph recipe, into different binary flavors in the same build. Okay, this will be the default. Using the build and host profiles in Conan 1 is not the default. At the moment, it's using always host, let's say, profiles for the builds. But this in Conan 2.0 will be the default. If you don't specify nothing, you do just Conan install. By default, it will be defined in profile host equal default, profile build equal default. It will be the same, but still you will have the build profile and the host profiles always. Okay, the new tools, the new transparent Cmake integration that I was showing you earlier, for example, they already use this model. Okay, they are prepared to handle this cross-building scenario and this build and host model. We are already using this in production in ConanCenter. Actually, the M1 builds that we are building for the M1 architecture in OS X, as we don't have the machines in the servers in CI, we are cross-building them with this solution. We are using the build profile and the host profiles to be building this way. Okay, in case you are old Conan users and you have been using the OS build and arc build settings, please don't use them anymore. They are going to be removed in Conan 2.0. And recall, this is something very powerful. It's something that with a single instance of Cmake cannot be done. Okay, and finally, before we run out of time, the small surprise. This is going to be, the first time that we saw something about Conan 2.0. I'm going to show an example of Conan 2.0. Hopefully everything will be okay. And it's prime in the world. We have never shown anything related to Conan 2.0 ever. So Conan 2.0 contains many things. Okay, Conan 2.0, by the way, is now in alpha stage. We have released something in GitHub and in PyPy, so you can do a pip install Conan equal 2.0 alpha 1, and it will be fetching this new alpha. It contains many things. The one that I'm going to try to show you today is the new graph model, but the changes are going to be massive. For example, it will be you always using the two profiles that I was showing. There are more powerful and easier log files. If you have been using log files in Conan 1, Conan 2 probably you are going to love them because they are going to be much better. There will be a new CLI. There will be modular commands, so you can create your own extensions and your own Conan commands. It will publish finally the Python API, which is a very requested things, and it's going to remove a lot of legacy things. Okay, so let's see if I can explain in these 10 minutes a little bit about the Conan 2.0 new graph model. Okay. The problem that we have in Conan 1x is that the requirements model is relatively simple. Okay, so you have requires for libraries. You can have this application. You can have an app application that requires the chat library, which in turn requires the hello library, and everything is a require. Okay, and it is good enough. It's doing a great job so far, but of course we realize that we are C and C++, and we always need more power. We want more control. We want more power, and this is what Conan 2.0 graph model provides. So what it is adding here to the model is two things. First, the package type. The package type is a specifier that they say, hey, this package is a library, or it is a static library, or a shared library, or an application, or a build script. It will add more information about what is contained in the package to be able to use it. Okay. By the way, these things are not necessary. I'm going to show you the recipes. And actually, they are not necessary to write. They can be also deduced in many cases. Okay, the same with the requirements. The requirements will be adding traits. The traits, for example, for the requirements can be thinking, hey, when you are requiring this library contains headers. You need to add something to your include deals because you will be needing these headers. And this package contains libraries. or this is a big requirement, or this is visible and can create conflicts, or no, it's completely private. So there are a bunch of requirement traits that you can use them. Okay, in the general case, it's not necessary. Okay, so the requires will not be more complex. I will show you the code here. But the idea is that with these two features, you can do something like this. For example, something that was requested. It sounds kind of dummy or simple, but it is not, because it allows architecture at scale, and it allows creating your big dependency graphs and maintaining sanity. So with this new feature, we have this setup. We have app depending on chat and depending on hello. In Conan 1x, the headers of hello are automatically visible in app, because as everything is required, you don't know anything, then you can directly do an include of a hello header directly in app, even if app didn't declare the hello dependency. And this is not good. If you want app to be directly including hello headers, you need to include a dependency that requires in the app recipe to the hello recipe. Okay. So what the new model is doing here, let's say that we have all the static libraries. By default is that the two explicit requires on the right is deriving an implicit require on the left that has changed the properties. In this case, the headers by default will not be ready. Okay, let's see it in practice. Let's see if I manage to make this work. I'm going to change my Conan version. Let's see if this Conan version, Conan version, and as you can see that I'm in 2C. Okay, I'm going to move to the graph. You can see that here that I have my three packages that I described in the slide. So I can do a Conan for hello, and do a Conan export chat, and then finally I can do a Conan create app. Okay, first change, we disable the automatic detection of the profile. Okay, there are reasons for this, but basically you need to say a Conan profile detect. We want to make this explicit. We want to make the users aware that they are using a default profile, and the default profile has this form. Okay, so let's create the app. Okay, I need to build my dependency, so I will be adding the build missing. Hopefully now it's building the hello package from source. Okay, come on. Now it will be in the chat package. And finally, is building the app application. Okay, testing the application, and we can see the application here is calling the chat library, which in turn is calling the hello library. Okay, so the important part here is that if I try to do this, I'm sorry. Okay, if I go to my app application here and I try to do this, okay, it will try to build the app from sources, and hopefully it will fail. It will tell that it doesn't have visibility over the hello headers. It was able to link with the hello library, but the headers are not visible. Okay, this is important. This is important for the architecture. Furthermore, we can see now that if I do again a Conan create app, this is very important. Okay, this is a big change here. As the application was already built, by default, the libraries are static, the chat package and the hello package are no longer needed. I don't need the binaries. If the binaries were not in my cache, they will not be fetched. Only the application will be fetched. And this can bring massive improvement, massive speed ups to Conan, and also further isolation, because it will have better builds, because dependencies will not be added. I will show you, yes, 4 more minutes. So this, for example, this is what I just explained. If I do an install of the app, the static libraries are not fetched at all. They will not be downloaded from the server. Only the app will be downloaded from the server. Okay. And if, for example, I change and I do a build of my chat, I change it from static to shared library. Okay. Then the application knows that it doesn't need the hello library at all. It will not be propagated. The linkage requirement of hello will not be propagated to the application. And the binary that hello that is embedded in the chat will be actually skipped as well. So let's try that. I can do something like Conan create app. I'm going to specify now that my chat is going to be a shared library instead of a static one. Okay, now it's rebuilding my chat, of course, because chat now is a shared library and it needs to be relinked. Okay, it's running. As you can see also, Conan does automatically manage all the environment. So all the shared libraries that they need to be added to the path to be able to run the application, they are automatically added to the path. Okay, so here we can see, in this case, the hello library was necessary, sorry. The hello library was necessary here because I needed to build the chat shared library. But if I do, again, the same thing, it will be fast, and I can see that the hello is actually skipped. It's no longer necessary. Okay, so this is very useful. For example, if you have large dependency graph that you have a shared library that is embedded 50 different static libraries, and there are users that have this set up. Okay, and you have already pre-compiled this binary. When you are building the application that uses this shared library, it will no longer fetch at all the 50 transitive dependencies of the static libraries, and it will not link against them by default. So this is, I'm very excited about this feature because this is very, very powerful, and I think it will be a massive improvement for users. Okay, mostly on time, just 2 minutes. So there are tons of resources for you. The main point of access is the Conan.io. From there, you can navigate to the GitHub. You can navigate to the JFrog Academy courses. The Conan course there is also free, okay, and it's very good hands-on training course. I strongly suggest this. The community out there of Conan is amazing. In the Include CPP Discord and in the Slack, the CPP Alliance Slack, there are Conan channels which are very active, and there are lots of friendly and very helpful people there to help. If you have any issues, by the way, the best is GitHub issues. Go to our GitHub and file there a ticket, and we do support there in GitHub for questions and problems. It's not only for bugs and feature requests. If you have a question, you can also send a ticket in GitHub. And yeah, recall that if you want your Conan t-shirt, and please also, you can rate the speaker. You can do feedback about the talk. So if you go take this QR, or this URL, it will drive you both to the t-shirt to get your t-shirt, and also to the rate the speaker and give feedback to the talk. And yeah, just on time, perfect, 1 hour. And thank you very much for being there and listening. And now, if you have any question, I will love to respond. I nailed it, 1 hour.
I'll let you know that I will need to stop the recording.
Yeah, go ahead and kill the recording, and then I think we can stay on and do questions.
Yeah, absolutely.
Okay, I'm stopping the recording.
Okay. Thanks, Robin.